Hi everyone. So this is about the walkthrough for week 3 lab. Sorry about the late posting of the video. I'll try to upload the solutions for the next assignments as early as I can. So unlike last time, I have done most of the things that was given as questions, so that it doesn't take me more time to type it down. So let's begin with what was the problem for this perception assignment. So we have imported all these things. So this was already done, and there are Vega dataset. As you can see, you can install it as a module, and then from that Vega dataset you can import data, and then you can see the list of all datasets that's there. And for the purpose of this next experiment, we have imported the local data and then checked the list of datasets that we have. And then we decided to have the ANSCOMPARE dataset. You can check the description, you can check the head. So these are pretty routine. There is nothing that I think that needs explanation. Okay, so the first question was, can you draw a scatter plot of the dataset I? As you can see, there's different series of data for this ANSCOMPARE dataset. So what I did here is just basically, doing a slicing from the data frame. If you set df.series is equals I, then it will basically slice the data set so that only the rows that has the series I that will be selected, and then you can just use the regular matplotlib plot function, giving the x values in the x-axis and the y values in the y-axis, and then the type of the plots is gonna be scattered. So if you execute this, you're gonna see something like this. So again, show you how to run this from the beginning. It's taking some time. Okay, I don't know what's going on. So okay, let's keep on walking through on the next question by the time it's done. Okay, so then we are importing a different dataset called the dataset cars, and then we're checking the head and then the whole description of the dataset. And you can draw a histogram out of this. I have already executed this code. So as you can see, this is kind of overlapping because we are not passing any value. So, and then the question is, you can check the documentation. You can just call it by hist, or you can pass values if you want. So for example, we want you to make the figure larger so that the labels are seen clearly, and then the layout becomes 2 by 3, not 3 by 2, and then change the number of bins, which is essentially the rectangular bars. We need it as 20. So what you can do is you can explicitly mention that. So you can mention the layout, which is 2 by 3, and then the number of bins, which is 20, and then there's bunch of different parameters that you can pass. So say for example, the figure size. So since we need to adjust the size of the figure so that it becomes larger, so you can see the size in inches. So you can play around with different sizes, and something that becomes more that renders the best view, you can pick that. So we have done this 12 by 8, and so basically this is a tuple. Okay, this is a tuple. So that's what we are passing in inches over here. So this essentially gives you these views, which is pretty much clear and pretty much what we want. Let's see. Okay, it's still running. I don't know. Okay. And then moving on, we have to check the Stevens power law and then the hypothesis experiment if this works. So essentially what we are doing is picking up a length, which is we are doing it at random. We are generating a random number from 1 to 10, and then checking that against, we are trying to draw histograms based on that. So here the mystery length is something from 1 to 10, that's the random number. and then if you see here, we are passing it as the question marks because we don't know the value, and then we are like creating a function called run experiment once, which is basically doing the same thing, but we are just wrapping it around a function so that we can call it later. So we are creating a random number from within 1 to 10, and then we're trying to see, like, if we're taking it as an input from the user and then appending it into that. So we're basically maintaining two lists. One is the actual length list, which will hold the actual value or the random number that has been generated, which is unknown to us. That list will hold that values, and then the perceived length list is basically the length that the user inputs from console. So we are trying to see, like, if how the guess and the actual value, if they have any linear relationship or not, or something like that we will check later. We'll try to fit that into a function. So basically, once we run the experiment once, it basically plots the histogram on so this is the y tick that we have given, the 1, 10. So these are two different lengths, and this is the length that we have guessed. This is the mystery length. This is the short bar, this is the long bar, and this is the mystery length. Now what we are going to do is we're going to plot the function. So basically, you have seen how to plot a scatter plot here. So this is the list of x values, this is the list of y values, and this is basically the matplotlib-plot.scatter function that basically takes care of the rest of the things. Now plot your result using this scatter function that we have seen here, and then you can use the x labels, you can use the y labels to label your x and y axis. So essentially, I have already written the code here. So in the x axis we have got the actual lengths list, and in the y axis we have the perceived length list. So the actual length list is the actual length that was generated by the unknown number, and that has been kept into that actual length list list that we maintained. And then the perceived length is the length that we got as the input from the user. So this is how you do, plot the title and the x label and the y labels. And then after plotting, we're trying to see the relationship between the actual and perceived length list, if it's a polynomial function or not. We're trying to do it using the curve fit function from SciPy. It's essentially, you have to pass the function that you're trying to predict, and then the x and y values. So in our case, we're using this function as it's already given here, f is equals a times x to the power b plus c. So as you can see, we have defined the function here, the same function, and then we're trying to see, and we're creating a random, a fake data set, and then see if this works. So we're basically doing y is equal to x squared. We're taking 20 values starting from 0 to 19, and then taking the x squared as y values, like 0, 1, 2, 3, and then 0, 1, 4, 9, and then trying to fit that function using this curve fit function. If you see, I have opened it up here. It basically takes the function and then the x data and the y data, and then what it returns is the array. So the first one is the optimal values of the parameters, so that the squared residual of that function outcome and then the original value is minimized. Basically, this is an error optimization technique that we usually follow. And then there's a 2D array of estimate covariance, which we do not need for the time being. So what we do here is, so once this function is called, it returns these two values. We are for this assignment or for this question, we only need this, which essentially returns all the values of the parameters, so that optimization is done. So it will return that parameters like a, b, and c. So if you print it like this and format it like this output, then you will see it returns 1, into x to the power 2, which essentially means that y is equal to x square, which in fact we did before. So this function works. So now you have to feed your data. So the data is, we are using the same function that we defined here, and then we are passing the actual length list and the perceived length list that we defined here. So after running this, you can print this and then check what kind of relationship you have, like in between the actual length and then the length that the user have guessed. Okay, so moving on, we are now trying to see the perception of area instead of the length that we have done before. So essentially we're doing the same thing. We're taking two different radius for two circles, and then one random radius for the uniformly distributed radius. I mean, we are taking a random guess like we did before from 1 to 10, and then we are creating another circle. So if you run this code, you will see this is the first circle, this is the second circle here, and this is the random circle that we guessed and then we draw. And then similarly we're maintaining two lists. One is the perceived area list and one the actual area list, and then we're creating the same function like before. We're taking the perceived area list values from the user. We're taking it as an input, and then the mystery number, which is the actual area list, it's generated by this random function, and then we're taking it here and then we're appending it. So every time this function is called, we get a new pair of values for the perceived area list and the actual area list, and then we do the same thing again. We run the experiment once, or you can run it as many times as you want, and then you'll have to plot the results like we did. So here we are plotting the scatter function, calling the scatter function, so that the scatter plot of actual area list and perceived area list is shown. And similarly, we are giving the x labels and y labels and the titles here. And then we're trying to feed the same function that we defined before, and then we are passing the value of the actual area list and the perceived area list like we did before, and then we're trying to print this using the format function. So if you remember, the first return value which we got from here was POPD, which is an array of the optimal values of the parameters that we defined for the function that we created. So here this is the A value, and this is the B value, and this is the C value. So if you see here, the value is 0.69. so this is something like this. It's closer to the linear relationship. Had it been 1, then we would have called it a linear relationship, but since this is not 1 and this is less than 1, so I guess it's safe to say that we have observed a sublinear relationship here. So this is basically of the form y is equals 2.59 times x to the power 0.69 minus 1.84. So obviously this is not a linear relationship, because we know that the linear relationship is of the shape y is equal to mx, or y is equal to mx plus c. So this obviously is a sublinear relationship here. So this assignment was, I guess, pretty much straightforward. I guess that answers all the questions here. I will upload this video on YouTube, and you will see this on Canvas. If you still have any question or any concern or any question, like, there can be multiple ways these questions can be solved, so you are always welcome to ask, send us email, message us on Slack. Thank you.